So Alex has been a long-term member of NOVAC and has a lot of interesting things to talk about, and it's all yours.
So other people have, death and taxes as certainty. I think we as amateur astronomers have clouds and equipment upgrades. And if you're tuning in tonight, I'm guessing that's because of the clouds and this beautiful new moon.
Sorry.
That's all right.
Sorry. Just trying to get this full screen. Keep going.
Sounds good. All right. All right. And speaking of this intro slide, I brought it because nobody else at NOVAC has pictures, right? So yeah, of course. And these are not my best pictures, but there's one thing about them, right? Is that they were taken about an hour apart on the same rig out at Camp High Road, right? So as you can see on the left is Jupiter, Planetary, very, very different imaging. On the right is the like the very middle of the Orion Nebula with a lot of dynamic range, right? And so what I wanted to talk about is, there's a lot of I wish, there's a virtual poll of hands, so I can't see you and I don't know what you did, but if you image in the field, raise a hand. That's me. And if you image in your own observatory, raise a hand. And then if you image in a remote observatory, raise a hand. Right. So and I'm guessing that it's probably most people are either field or remote observatories, and then the lucky few have their own observatory somewhere dark. So what's happening is we had a presentation by Rob Capone before COVID. That's all I remember. I think it was 2019, about setting up in the 90s, setting up a robotic observatory. And I thought it was really cool. And it would be nice to do that in the field. And I think, we sometimes joke that there should be a separate imaging category for people who are out there with the dew and mosquitoes and so on, and, coyotes.
James has his hand up.
Okay, James, go for it.
James, you have your hand up?
That was probably
right.
from before when you asked people to raise their hands for this and that.
Cool. Okay. Well, thank you. I think it was a show of hands for field and so on. All right. So these are the two rigs I was talking about, but really I'm going to be mostly talking about the rig on the right. And as far as the equipment updates, that even changed, right? So everything's changing constantly. We of course have lots of robotic telescopes. This is on a Paramount, right? I'll talk about the details of that in a few minutes. But now we have strain wave mounts, right? Strain wave mounts are much smaller. So on the left, there's the M5N. That's a strain wave mount holding a refractor. But there are strain wave mounts, AM7 and ML Astro and so on, that can hold this C11 that's on the right. They're powerful enough, right? It's different technology. Okay, so why are we doing this? I wonder about that all the time. You might wonder about it too. Things are, astronomy is expensive, right? Can be. And right. And then I've been asked, once I set up outside the house, I think I was trying to image Jupiter near opposition, and this delivery guy pulled up and he said, "Well, what are you doing?" I said, "Well, I'm imaging, planets." And he said, "Well, can I take a look?" And he took a look. He's like, "Why are you doing this? Hubble pictures are better." Like, thanks. Yeah, appreciate the encouragement. But for some paradoxical reason, it is incredibly nice when something happens. Maybe it's just because something happens as a result of this, right? But it's really amazing when you realize that this is all real. Right. I think at star parties we say, hey, the actual photons are, hidden in your eyeball that left 20 million years ago or whatever it is, right? This is real, and it's absolutely amazing when you get to see a picture, or when you successfully take a picture with whatever it is, or even see it, or however you reach this cosmos. It makes me shiver every single time. Never gets old. All right, so maybe not in a standard flow of presentation, but like Woody said, I've been a member of NOVAC for about 10 years. I was actually introduced to NOVAC by a Moroccan knight, of all people. It's a strange world sometimes. And I've done astronomy, amateur astronomy for about 13 years maybe. And then, so I'm about 4.5 Jupiter years old. Okay, so about 3 Jupiter years ago, about 2/3 of my lifetime, I did physics in a lab and in Soviet Union, and part of it was laser physics and optics. And the one thing I wanted to mention, I haven't done any of it. I'm just an amateur astronomer, right? I do IT for work, but I wanted to mention that there's a lot of equipment available, right? There's a lot of robotic, automated telescopes. They're wonderful. They bring people into this hobby, and I've seen recently new NOVAC members in the field very excited about this. This is great, right? And please keep doing this, right? But there's more to it, right? So it could be very nice and gratifying to just step outside the manual, right? Just do something more than the vendors tell you, right? And primarily astronomy is governed by light physics, right? And light physics doesn't really change. So in professional life, people asked me a few times is, how can I make this long distance network faster? What amount of money can I pay so the signal gets there faster? And the answer is, well, you have to go tussle with Einstein because, there's a speed of light issue. And so in the same way, with astronomy, right, there's a lot of, most of the limitations and most of the physics is what dictates the result, right? So let's talk for a second about why this automated setup, why invest time into building a custom rig or automated or do any of this manual stuff. So one of the reasons would be that you can be comfortable, right? So you can image, like I've imaged in high wind and very cold temperatures, 13 degrees, I think, this last winter, which, there's no dew. So it's nice astronomy wise, but it is challenging for a human, right? So it's nice if you could be in a car or, tent or a trailer or whatever. And for that, you need some automation. So at AHSP, I'll be talking about another side of comfort, is building the astronomy trailer with the said trailer available to look at. So that's part of astronomy, I think. Specifically for planetary imaging, right? So it's more like hunting, right? The deep space imaging is more like endurance, right? You just take the subs, and the longer you do this, the better result you get, right? But planets are very different, especially here. Thanks Jetstream, right out here, it is challenging. The seeing constantly changes. Planets are bright and they're tiny, right? So Jupiter, I think, is 50 arc seconds, and then and that's the biggest, and then the rest are smaller. And so they're constantly shifting bright small things, right? And so you have to kind of be there for it, right? And it's very hard to be there if you're getting bit by mosquitoes or if you're freezing or whatever, right? So it's nice to be able to control this whole situation from somewhere comfortable. Maybe it's a few feet away, but you're able to do it. Okay, and so the technique we use for planets is called lucky imaging. It's essentially taking a video, right? So the planetary cameras are essentially webcams, right? So you attach them to a telescope and you take thousands of frames, right? Again, planets are really, really bright, right? So what happens is, instead of taking a long exposure image, you take thousands and then you stack them with software, and then the software picks out the really good images or the best ones, right? And then you stack that and you get your final result. So that's very different than deep space. So deep space objects, you want long exposure, right? So I image That being said, people have done lucky imaging with DSO successfully, and this is certainly not to prevent anybody from trying, right? You might get good results, especially with brighter objects, but typically we image for, hours, days, and years and whatever. I have pictures of galaxies it took a year to take, overall, and the more the better, right? Signal to noise. We have a lot of light pollution. That's not getting any better. It's not going to change. And so filters, right? And filters further reduce the light that comes in, so you need even more time, right? So all of that is a reality with DSO. So for that reason, right? And by the way, when I was getting started, that hadn't changed, right? So it's really miserable to get started in astrophotography with a long focal length setup, right? Because it is the best way to fail, right? And that's the reason why pretty much all the robotic telescopes are short focal length, right? So you have, there's improvements in sensors, there's improvements in electronics and guiding, and so on. But still, if your resolution is limited by your aperture, essentially, right? So to image small things, you need large aperture. There's no way around it, right? You also long focal length helps, which aperture is a function of, but also just because the more of those pixels you can get on a sensor of the details, the better the picture is going to be, right? So that's the setup here. So that's a C11 Edge HD, right? It's almost a 3-meter focal length telescope. Autocorrect said it's defrocked, and maybe it's right. So it's kind of more of a wild side of the C11 off the fork. I used it on the fork for a few years, and it's been great. Actually, it's been used a few times at Udvar Hazy. I live in Maryland, so I volunteer at Udvar Hazy because that's the closest. We did have over 1,000 people, and it's fun to have a C11. Looking at stuff from the airport, you can still see things. But it was nice to get it off the fork and put it on a plate and a German equatorial, because that then allows for guiding and long tracking, and it certainly gets makes it possible to image deep space objects. Right, planets are fine. Planets you can image on the fork just fine. So again, this uses a classic mount, a Paramount MIT, which is the smallest software bisque mount that you can take in the field. Still has 60 pounds of counterweights. And I'm very close to putting this and trying it out on a strain wave mount, on a harmonic mount, and we'll see what happens. Right, they should be able to carry this setup. Right, you can see a whole bunch of equipment at the top. Right, so it's mounted on the telescope. Again, every little detail matters. Paul and I talked before this talk about how long it takes to set up a big professional presentation, right? So you spend months and weeks and months and hours and days preparing, and then there's this one situation where this one moment where everything comes together. This is exactly like that, right? The more time you spend practicing and preparing, the better the experience is going to be. So the equipment rides on top so that you don't have to have a lot of cables. The cables are kind of localized. Bader click lock, that is a really nice solution to especially back focus, right? So we'll talk about back focus on the DSO slide, but when you're imaging with these DSO cameras, right, the cool CMOS these days, used to be CCDs, it's very, very important to keep a precise distance between your flattener reducer, whatever, and the camera, right? It has to be ideally within millimeters of what it's supposed to be, right? And click locks have been a good solution for this specific type of telescope, just because they keep everything very nice and tight, right? And easy to switch, right? So motorized flat panels, there's two things I absolutely hate on astronomy. It's polar alignment and flats, right? So polar alignment, I did a talk at the Northeast Astroimaging Conference in 2022 on automatic polar alignment. I'm certainly not the first to do that, but maybe that's the first talk And I know that now there are robotic, Altazimuth is actually driven by motors on equatorial mount for automated polar line, which is awesome. I'm going to buy one of those and see what happens. But I did build one, and so you can not quite see this here, but in a different picture, you'll see it. So there's a motorized polar alignment, but also flats, right? So flats, ideally you take flats, either before an imaging session or immediately after the imaging session. And it just sucks because you're tired or you're excited to get going. And it just happens to be that the motorized flat panels just take all this pain out, right? Because they do it by themselves, right? They open and close and then light up. And again, the invisible show of hands that I'm not going to see, you don't need to click the hand in the meeting, but who uses Nina? So I use Nina, I absolutely love it. Big shout out to Nina developers. One of them is local, Dale Gent, developed ground station. Thank you, Dale. I use it a lot. You can control all this gear with Nina, which is free and open source. Very cool. Before that, I used to write Python for SkyX, from Software Biz, which was kind of fun, right? But it all kind of ended when Software Biz stopped supporting a whole bunch of cameras, and so Nina doesn't have this problem. So I discovered Nina, and it's been a really wonderful experience, right? So again, Pegasus makes this Uranus Meteo Station, so that measures your sky temperature. So it basically measures clouds. It measures your observing conditions, and that could be the hardware driver for your safety monitor, in Nina, right? So you can decide. So I had a telescope rained on, which was one of the worst experiences, I think, of my life. This freak storm came out of nowhere. There was zero chance on the forecast, right? I happily went to sleep. I woke up to trip breakers in the Takahashi 85 millimeter scope being soaked. It did recover, so it survived. I'm happy to report, but I don't want to have that experience ever again, right? So if you have an observing conditions monitor and you can close that flat panel and orient the telescope towards zenith, so whatever falls from the sky falls on the flat panel and not inside your barrel, that's a really nice thing. I haven't had that happen again, but it's really worth not worrying about it, right? So power distribution boxes on there as well. And you can barely see it. Maybe in a different picture it'll be better, but there's an older Pegasus power box, is it Ultimate Power Box version 2? I think they're out with version 3. Basically, it just routes your power and it has a USB hub. So you don't need to worry about, again, a rat's nest of cables coming out of your telescope and dealing with that. All right, so the other tool that's used here is OpTac Fast Focus. So that is a small actuator, or rather it's an actuator that moves in very small increments, and it's attached to the secondary mirror of this SCT, right? So you don't have a problem with the mirror flop, right? You don't need to move the primary mirror. You don't have a problem like with a Crayford focuser where you're changing your back focus. So it's a very nice solution. There is a manual focuser there as well, which is good to achieve rough focus for, especially when switching between planets and DSOs. But at the point of imaging, I would usually lock the primary mirror, stop using the manual focuser, rely purely on the fast focus to do all the focusing work, especially the automated focusing work. Nina has or rather ASCOM has a driver for it, or they have a driver for ASCOM that Nina can use. Finally, the reducer. So the reducer is used for DSOs. So planets you want to image with a huge, as much of a focal length as you can, right? Because planets, again, are very small and they're very bright. So you want that image to cover, or the details rather, to cover as much of the sensor area as you can, and hope that the weather is decent enough, seeing is decent enough that those details are actually not like a blown up picture on the phone, where all you see is pixels, right? So, okay.
Someone's asking what cameras are you using?
Right, that's coming.
Oh.
All right, well, so I talked about the Feather Touch, so that's basically the manual rough, and also absolutely wonderful to use for visual, because you can use this for visual just fine. With with the manual focuser. There is an additional guide scope. Fun part of it, it's not really a guide scope at all, right? So you see that second tube. It is not used for guiding. It is used for rough alignment, right? Because planets are, one thing about planets, right? Like I said, it's kind of like hunting, right? They're really hard to find, right? And the more tools you have to find your planets, the better, right? Because you can just point, like you can see planets usually with your eye. They're not hard to find with your eye. They're just really, really hard to find in the field of view. So if you have something else, right, then what you have is basically a very wide field scope. And then there's a ASI 120, a small camera attached to it. And so you can get like short hair, what do you call them, crosshairs in sharp cap. And you can align with the planet with that, drag the crosshairs, and then you can bring that into the field of view of the main telescope. So that's a really nice tool to have, right? Failing everything else, there's a Rigel Quick Finder, which is kind of like a lightweight Telrad. And you can just find stuff with your eye in there, right? With concentric circle kind of illuminated finder. There's a Polemaster as well, right? Polemaster is just a little camera you stick to the on the polar axis of your scope and rotate it, and then there's software that will help you polar line. A mini PC. There's a lot of people use different kind of mini PCs. I just use the cheap one or cheaper one that you can get, on anything online. And they have plenty of horsepower, right? You can just stick them on and they're good enough to do video. They're good enough to do GSO. So that's what's on there. That's a little gray box. Not sure if there's a laser pointer there.
Yeah.
There it is. Okay, beautiful. So if you can see this, I doubt you can see this through the camera, but it's to the right underneath the ASI 120. Okay, for an SCT, and this of course, this big light bucket, but it's also a big heat bucket. So the problem with these big SCTs is cooling them down to equilibrate them with, the outside environment, with the outside air, and force cooling is amazing, right? Because you don't need to, you don't need it to sit there for hours, or maybe for an hour. But the cooling fans are very helpful there, right? They're just built in around the primary mirror, and that's that. Celestron heater ring. So again, dew is part of life for us. Kind of like maybe I'll add a third one, right? So death and taxes, and you have the clouds and equipment upgrades and dew. So for that, again, there's different solutions. Of course, you have heat strips, little dew strips. You put just behind the corrector plate, typically, or in front of the corrector plate, creates a little cushion of air in your telescope that keeps out dew in the dew shields as well. This being a Celestron telescope, there's a aluminum dew shield, which is helpful there as well. All right. Often overlooked and very important is cable management, because cables, first of all, it's really nice to know what cables go where, right? It's kind of like when you get out in the field, at least I get really dumb all of a sudden. At home, I'm going to plug in cables. I know intuitively in my sleep exactly where they go. You go in the field, you have no idea, right? So also cables snag on equipment. So it's very nice to have right length cables. You can trim them, you can wrap them, you can do whatever you can do, make them small, right? So that's the, USB and power, right? And then I found that, solutions, there are solutions that are not like approved astronomy vendor solutions, right? So book stand metal clips is the little things you put on to hold your book. They sell them for $5 or something. They're amazing to keep cables out, right? So if you again look at this, the metal clips are here on the side of the telescope, right? Identifiers for ports, again, you want to kind of think about what do you do in the field when you plug in these cables. If you have these little clip-on identifiers or whatever method works, right? Little labels, color code, whatever works for you, but knowing what goes where is priceless. Minimizes setup time, and most importantly, makes the whole setup predictable, right? If the cable doesn't move, then tie it up, right? Because if, you know, some things need to move, they have to, right? So, you know, these cables have to move. These cables have to move, but nothing else does. So tie them up and get them out of the way, right? It's nice to, again, if you look at this setup, right? So this will keep the same in transport. I can take it in the car, right? Bring it out. There's a little metal handle up here, right? And so you just bring it, and this is just old stuff bought on, you know, eBay or Amazon or whatever. And so no affiliation. I don't care where you get it, but there's a whole bunch of this cheap and well-made so a set of components available for these kind of setups, kind of like fun Legos for adults. But in any case, that all helps out to move the thing, right, and keep it together, right. And then finally, practice, right? Because again, when you get out, you know, if you're figuring out your cables when you're in the field, that's not going to be fun, right? Practice them before you leave many times, and then that's going to really increase the chances of success in the field quite a bit. All right, so we're moving on to the planetary setup for this. And again, you want to use the full focal length of the telescope for planetary because, you know, details are precious, and you want to resolve them as much as possible. So there's no reducers here. Back focus pretty much doesn't matter for planetary, again, just because of the tiny size of the planets. And the other thing, besides Hayton polar alignment and flats, I also really don't like moving the atmospheric dispersion corrector levers in the dark, right? So if you've ever used, and if you haven't, you probably should for planetary. So atmospheric dispersion correctors are a pair of prisms that essentially minimize the color separation, you know, that happens. It's not a problem with the telescope, it's a problem with the atmosphere, right? As light goes through the atmosphere essentially separates colors for planets, you know, they're bright. And so the ADC brings them together. So it's a wonderful thing. But if you're using a manual ADC, that means that you have to constantly adjust a couple of handles, right, at night, and they have to be the same, right? So I thought about it, and, you know, some time ago, and I figured there's got to be an automatic way to do it. And there was, right? So this Chinese group, a very small Chinese group, made electronic ADC. That's this box here. And it essentially moves the prisms with, you know, motors, and it adjusts for an altitude. I wrote an article about it, or a little thing about it, on cloudy nights, and there was some kind of back and forth, and then I think there was consensus that yes, this is a decent thing to have. And then I actually wound up seeing Astro UTEC at NEAF, at the Northeast Astronomy Forum, bring it on the floor, and, you know, you can buy it, and that's a wonderful thing. But it is very helpful, right? Just because, you know, especially if we're imaging low in the sky, and right now, like, Jupiter's pretty low in the sky, so there's a lot of atmosphere between us and the planet, and that atmospheric dispersion effect is going to be very pronounced, very obvious, right? And you can't really, yes, you can have the software correct for it, but it's not going to do as good of a job, right? Because the effect is already there, right? It's already captured. So by correcting it before you capture it, you're going to have a better image. All right. So further, when we're imaging planets, we want to pull this image out, you know, kind of drag it out as much as possible. So Barlow's and power mates. Right, and honestly, 2.5x is kind of as good as it gets in this environment here. Not even, like, it's very optimistic, but this just makes it a huge focal length scope, right? But you're pulling out everything you can in hopes that you're pulling out something reasonable. And the moment you capture it, you're gonna know, right? Because you're gonna see this sort of sharp image in the on the video, and that's the time to get it. All right, now you asked about cameras. So I was actually use a 685 right now, but they're essentially they're kind of like a monitoring, like a home or whatever, security monitoring cameras is what these. They're Starvis 2 sensors, and ZWO makes a bunch of them, but so do a lot of other people. But essentially, they're webcams with noise suppression, right? So that's this guy right here. And quite a few people use them as guide cameras. They're perfectly fine for that. And you could take a guide camera, one of those, and use it as a planetary camera. So what matters for planetary cameras is sensitivity, sensor size. So 294, that's an older camera, but that has a huge sensor, right? So if you're having trouble finding your planet, that's kind of nice because you're going to be able to find it better because you got a bigger field of view on chip. Right, these are smaller, but they're kind of nice because they have better sensitivity, better noise suppression, and so on. So the click lock adapter, you can see. So this is literally you just turn it about a quarter turn, and you're able to change the imaging train, and it just stays where you put it exactly. Which becomes important when we come to the DSO train, the deep space object imaging train. So you asked about the DSO camera. So I absolutely love this camera. It's an older camera made by ATIC, and it used to be QSI, ATIK. And it's one of the first CMOS I think they made. It's not a CCD. They used to make just all CCDs. So they made the CMOS. But the nice thing is it's all integrated with the filter wheel. So it's one unit, right? So the cooling, the deck cooler, the camera itself, the filter wheel, they're all one box, right? So you don't need to take it apart. It all works together. And it has a prism, again, integrated for the off-axis guider. So there's an off-axis guider, Lodestar Pro. And you just attach it to the imaging train and it's good. So the problem is, and that's not the only camera I use. I just really like it. And I like to continue to use it. But I was trying to use it with SkyX from Software Bisque, and they just wouldn't support it. Yeah, just said it's an old camera. Get something better. I'm like, well, I don't want to get something better. I like this one, right? So sure enough, plug it into Nina, everything works. So that's how I got started with Nina. So that's a 690 WSG, which means that there's a filter wheel integrated. In that filter wheel, there are, obviously luminous, red, green, and blue RGB filters, but also narrowband filters, which make it possible to image during, with the moon out, with light pollution, still a whole lot of stuff gets through, as far as the deep space objects that you can capture. Okay, and then back focus is really important here, right? So this distance, the distance from the reducer and the camera is very precise. So again, putting a focuser there is probably a bad idea for DSOs. And so having it rigid like this is nice. Okay. So, and again, attaches, detaches as one unit, and you can do the same thing. Look at this other rig, go all the way back. Yeah. So if you look here, this is kind of a different take on that. So that's a QHY 900 PH camera, cool DSO camera, and a QHY filter wheel, but they also attach, detach as one unit. So you can achieve much the same results. Okay, polar alignment's important, and I also hate it. And so, it's nice to pre-align if you're out. And again, if you listen to, I don't know, if you listen to Roland Kristen, maybe not a bad idea. He says, okay, just put a solar finder and then, find sun when it's out, right? Slew your telescope to the sun, obviously covered, obviously don't look at it, but that gives you a decent polar alignment. That's true. But what if you got there after the sun is, set? Well, you could still sort of polar align, set your compass to true north. It's not going to be exact, but it's going to be something, right? And then as many options as possible, have as many options as possible to, to get to that polar alignment quickly. right? So you have a whole bunch of options. Nina has a 3-star polar alignment. It's very nice. It's actually now integrated with robotic polar alignment devices. Like the ML Astro one is integrated. I use my own, but still, it's nice to be able to move the telescope remotely in altitude and azimuth for that, right? This pole master, which you can just rotate the telescope a little bit and achieve a very good polar alignment with that. Sharp cap, again, if you look at this 120, right? So if we look at the guide scope, so to say, right? It's good enough to do polar alignment with sharp cap, right? So, and it's pretty easy because you can see a lot. It's a very wide field device. Why would you use those and not your main camera? Because especially at a long focal length, you may not get enough stars to resolve, right? And you may, polar alignment, so like, why not just run a Nina 3-star polar alignment with your main camera? Absolutely, you should, if you can get it, right? But if you can't get it, then having a backup plan and a backup plan for the backup plan makes it much easier to image in the field. The other thing you can do, the other trick I found, and not just for polar alignment, is to use the guide camera, right? So if you have an off-axis guide, or this guy right here, right, you can bring that image up, and you can do rough focusing with it, right? Which is important because especially in this kind of setup, I'm switching between planetary imaging and DSOs, right? And you got to refocus, and it's very nice to have a tool in the main imaging path that allows you to refocus. So that's one trick that's really helpful. Okay. Finding planets is hard, right? Because again, they're tiny, they're kind of all over the place, and you can see them, but yet your telescope doesn't. So how do you do it? Honestly, a lot of times you just wing it. Just look at the planet, kind of point the telescope there. You'd be amazed at how good you are at it. But here's the science, right? So you can, first of all, find a bright star somewhere, right? Which you can do with your main camera, result plate solving and whatnot. And then just align all the optics to it, right? So make it sort of collinear there. So align the finder scope, this tube here, and then get the optical aid also aligned on the same thing. It's done so that later you can find things quickly, because it's not going to help if you found the planet and then you lost it, right? So how do you find it again, right? So if you're basically all pointing to the same, all your optical axes are pointing in the same direction, then you can find it. All right, so secondary camera, right? So things like sharp cap, again, they have crosshairs, so you can find the planet, align, and then you can find it again and again and again. Fire capture. So I use fire capture, which has an auto center option, which will basically just bring the planet back to the center of the view and it definitely will happen to some extent, right? It's going to drift across the field of view as you're imaging it. And so this feature will sort of electronically keep it centered. All right. And then focusing. So I've been asked a few times about auto-focusing on the planets. And my take right now is it's a myth. It doesn't exist, right? There is no automatic focusing on the planet, right? Maybe at some point with some AI tool that'll happen. It just doesn't work right now, right? So the only way that you can really focus on the planet, first of all, the planet's going to drift in and out, right? Just because of the constant changing and seeing. It will never stay in the same focus. So the DSO methods of, hey, I'm going to find something and I'm going to stay there, it's just, again, not going to work, right? That's why we have lucky imaging, because you're capturing these drifts and you're just picking out the best of those images in your stream, right? And so, again, the only way that I know that you can reliably focus on the planet is by eyesight. So you could focus on the moon, you can focus on the feature, but pretty much if you see a feature, so you see the Cassini division in Saturn, or you see the Great Red Spot, you just kind of came into, or the storms on Jupiter, you're in focus. Just stop. You're good, right? If you've seen it, you're fine, right? But getting there takes a little bit. So right focusing, so I first rough focusing with the manual focuser kind of gets you there, right? Actually, again, gets you there pretty well. And then fine tuning it. And, there's going to be a bit of this. Did I really see it? It's nice to just mentally note, okay, here's the focusing length, or here's the focusing number that I was happy with, right? Just kind of write it down on a piece of paper, keep it in mind. And then you'll travel back and forth, but at some point you're going to just come back to roughly that value and stay there. All right, collimation, if you have an SCT, of course, but collimation is really important, right? You can't overstate how important that is, because an uncollimated telescope, you just can't reach that precision. You can't reach that crispness of the image. So you have to collimate, and it's annoying. And maybe it's a little bit uncomfortable because you got to turn the screws. There's some aids for that. There's some software for it. However you do it, do it. All right, so already talked about the kind of glimpse of features. If you glimpse the features, you got it. This is it, enough, right? And then during acquisition, focus will drift back and forth. There's nothing you can do about it, right? Just let it drift. You found that middle. You stay in the middle. Let it drift. It'll be fine. Okay. Again, using fire capture, which I do, and SharpCap probably has a similar feature. But there's an ADC, so there's a automatic dispersion corrector tool, and what it'll do is it'll kind of give you this estimate of how color aligned you are, and that's a really good aid. You can crank up gain, and you're going to see this fringing. So you kind of want it to be roughly equal, right? So the blue and red is what we see the most, and you kind of want blue and red to balance as much as possible. Okay, and then DSO for, again, back focus, incredibly important, right? So that gives you your, primarily the flat field. And in this case, I'm using a rigid setup with a Bader click lock to just keep it in place, and it's also a very quick change, right? So there's no threads to deal with, which is very nice. The other thing often overlooked, right? If you're switching imaging trains, the mount will unbalance, right? For some mounts, it doesn't matter. I hear that for strain wave mounts, balance is actually not a good thing. We'll see, but for classic mounts, balance is important, right? And all this gear will matter, right? So rebalancing the mount's important. I can't tell you how many times I spent, well, maybe I don't know if hours, but like an hour figuring out what is wrong with my setup, only to understand that the location and time were not correct. Right. So I'm imaging from, Spruce Knob, but my mount thinks that I'm in DC. Or one time I think the extreme example of that is I was at the helicopter landing site, and my whatever happened in the software, it just flipped east and west. So I was somewhere in Uzbekistan, or at least the mount was. So that's important. So location and time. So like that should be a habit and maybe an obsession to just set that up first. Okay, so Nina, show of hands that I can't see. Who's ever used Target Scheduler? If you have, it's great. It's amazing. If you haven't, check it out. There's really good videos online about Target Scheduler. Target Scheduler essentially kind of works like a remote observatory. It is built for remote observatories. You set up your list of targets. What are you interested in? What do you want? How do you want them captured, right? And then you just kind of feed it into this little database. And then Nina will take care of all the imaging for you, right? So it'll find your targets. It'll find what's best right now, right? Go to the target and just process them in sequence, and then take your flats for you and all that. So it's absolutely wonderful. Dale wrote Ground Station for Nina. Ground Station is the way to send you notifications. So it can send you text messages, or I use this service called Pushover, or whatever you use. You can use it, and it'll let you know what's going on, right? So you can configure this in the advanced sequencer in Nina, and essentially know what's going on without having to look at the screen, which is very nice. All right. Well, that's what I had here, right? I did want to talk a little bit more about things like kind of maybe controversial subjects, but maybe AI in astronomy. And I don't mean hallucinating pictures, but more like driving your rig and driving your workflow throughout the night. I think there's great opportunity here. And I don't know what's going to happen or if anybody's done anything with it. This is not my computer with the slides, but on my computer, I fed my target scheduler automating or advanced sequencing file into both Claude and ChatGPT, and I said, "Hey, do something with it. You know, figure out what's going on. Explain it." So Claude built me a whole PowerPoint presentation on that. I have that. I can't show it here, maybe some other time, but basically, it's pretty good, right? And then they both created a modified file that you could just load into Nina with no input at all from me, right? And I loaded it, and it works, right? So I think that there's some, quite a bit of opportunity there to make this imaging workflow better. And then the other, obviously, the other big thing is strain wave mounts, right? So strain wave mounts or harmonic mounts, they really only were available in high precision industries because they required themselves high precision to manufacture. But now that's available. Now we can do it. Right? They're small mounts. They're very portable, and they're very strong, right? Precise and strong. So I think that that's really changing our hobby quite a bit. Well, I'm happy to take questions. Here's a couple of reference items if you want to reach out later or take a look at what I've been doing.
What's an easy way to figure out back focus when you get a new scope and you're not sure exactly where it's going to fall?
The easiest thing is to look at the manufacturer spec. They state it exactly, right? So back focus is important. Well, first of all, it's really only important for deep space imaging, right? It's not important at all for visual, and it's not important for planetary, right? But you're typically going to have an optical element at the end, the reducer or flattener, right? And all these devices are manufactured with very precise back focus spec'd out. So it's going to say, so I put astrophysics telecompressor recently, and it says, on the telescope, and it says it's 95.3 millimeters, right? Ask your favorite AI agent or Google or whatever about adjustments for filters, because filter glass will change that slightly, usually within 1 millimeter, right? So mine's actually 94.6, like that, right? So yeah, the spec is really the only way to do it. Of course, you can measure it, but it's kind of hard.
On mine, it would say 55 millimeters, but when I would set it at what I thought was 55 millimeters, I'm never sure exactly what the reference point is on the back of the OTA.
Right. So again, the specs will say it, right? So for a flattener or for a reducer, it's going to say, okay, from the back of the reducer, right, which is a sort of a clear line, right, to your sensor. Typically, camera manufacturers will specify exactly the distance from the front, right? So from the QHY camera I have, for example, the QHY PH600 or 600 PH has a sort of a swallow's tail mount in the front, right? And from that point to the sensor, it's the exact distance they tell you. They also draw a line on the camera where that is, which is nice. But you basically just measure it with calipers.
What I did was take a piece of ground glass and found the focus point, and then measured that, and it never matched what the manufacturer said. That's what was driving me crazy.
It can, yeah.
So I'm just wondering, what am I missing?
Well, you're looking for a flat field. Again, I'm not an expert at all, right?
No.
And so I'm kind of like, again, I'm like ChatGPT, right? I'm a great expert in anything you're not.
Yeah.
But I would look at the manufacturer spec. I have seen on cloudy nights and so on reports of some variation there, right? So there's going to be maybe about a millimeter here and there, but the general consensus is just don't worry about it. If you're within a couple of millimeters, that's fine. Because a lot of times without standard extenders and standard hardware, you have to go find a way to manufacture an extension, it's probably not worth it.
Yeah.
Right? But there's also tools that'll measure your curvature in your image.
The other way is to order 20 or 30 extenders and, until you get the right ones. They keep coming every day until.
Yeah.
it works, right?
Yeah, no, that's true. That's,
And you
I mean,
get a
it's
whole
cheap
big
enough
jar of
and it's good
extenders.
enough. I think in this hobby, at some point, you accumulate a closet of things you don't use.
Yeah.
Right? And it's just there just in case, but every once in a while, you find this one thing that's really useful in that closet. So
Here's a
that's probably
Question
an
for you from
example.
Eric Benson. He says, between your refractor and your C11 SCT, which do you typically spend more time with? And does it depend on targets, time of year, location, or portability?
It's a torture every time, right? Because they're both wonderful. And so, but I did imaging one night from a dark location. I think you and I talked about it near Joshua Tree National Park, right? And I don't know how you get an SCT, an 11-inch SCT there on a plane, right? I would never dream of checking that, right? So the refractor was really the only option. So I took a 85 millimeter refractor there, and it easily fit into a backpack, right? So again, it's sort of like what they say about cameras, right? What camera you should get, the one you're going to use, right? So which telescope, the one you're going to use. They're both great. Again, refractors are easier. Not all refractors, right? You have long focal length refractors that are basically sails. They're very they're great. They produce wonderful images, but setting them up is hard. And so, short focal length refractors, little refractors are, portable, right? So first of all, you can get them places easier. They're really fun, but long focal length things, if you're ready for long focal length, and again, I started with planets, and I do recommend that because planets are just more forgiving. So if you start with planets, you kind of work up to this DSO at long focal length, and that's okay. But I would say that well-maintained refractors and SCTs are both great. I can't tell you one over the other, but all things being equal, if you want something that's easier and more practical, definitely refractors. All right, because specifically for imaging, right, not for visual, but specifically for imaging, refractors are going to kind of give you more instant gratification than SCTs.
What about Newtonians?
Have no experience with them. I've looked at other people's, and Dobbs, of course, right? So AHSB is a great place to go and look in other people's scopes. It was very, very satisfying, especially you don't have to hold.
So this is a newbie question. So you're taking videos of the planets, right? And then what software how do you pluck out the
Oh, yeah.
sharp?
So there's a few different things, right? So the one I use is called Astrosurface, right? It's a free software from France. It'll kind of do everything.
Surface or surface?
Surface, like a planetary surface. So Astrosurface, a lot of people use AutoStacker, right? That's still around. I don't think that's been maintained for a while, but it works, right? It's kind of longer. The only reason I use Astrosurface is about 5 times faster, right? And then there's a Lucky Image Stack, right? So Chris Go uses that, I think, at this point. And that's also free open source software, and that's been great. I haven't tried it.
So you just feed the video.
Yeah, so you capture the video usually with SER format, which is basically a lossless format. You could do AVI, but typically SER is what you capture, for Lucky Imaging, and then you just take the whole file. So the file is typically on a 585 camera, ASI 585, and I just use color cameras, right? I don't bother with monochrome for planets. They're good enough. So that's probably going to be, 300 megabytes in a 300-second capture. That's good enough.
300 seconds.
Well, 300. So one thing about planets, right, is rotation. So you want to, Jupiter and Saturn will move meaningfully out of alignment essentially in your picture, and by alignment I mean just kind of pixels staying in the same place within about 5 minutes, right? So those captures are typically about 5 minutes.
SER format. Okay, I'll talk to you.
Yeah, Sierra Echo Romeo. All right,
Any more questions? Rob or Paul?
anything in?
Nope, no more
All right,
questions.
well, this is it then. Thank you, guys.
Thank you very
Clear
much.
skies.
This is a great, first of all, let me give you something, can't see very many of these, because we're down to like 2. So,
Oh,
thank you very much.
All right.
We'd appreciate it. And so NOVAC, coffee cup, we, like I said, I think we have 2 left. Yeah,
All
so,
right.
try to get them to people when they actually come to the program. And, I also wanted to, say, this is, we have a lot of different speakers, and this is one that really goes to the heart of the club. A lot of people are really interested in this sort of stuff, and we really appreciate it. And I know there's lots of other questions that people will get back to you about. And I know you're happy to help people.
And I'm happy to learn from them as well.
Right, and we have a lot of good people in this area. But on the other hand, I want to say to other folks who are just joining this world, don't get overwhelmed. This is easy to get overwhelmed. There's a lot of things going on here. There was a very technical presentation, but there's a lot of other ways to do this. This is what I want to get at. There are a lot of other ways to do this, and a lot of people do it in other ways. And but we have experts here that can help you learn how, and want to help you to learn how. And at the same time, we have a lot of, like I said, over time, we have a lot of different speakers on a lot of different topics. But this is also one of the things that the special interest groups do. So if you have a special interest in this, this is one to really get into. And I also wanted to say we have some visitors. So we cover you 4 maybe. I was watching y'all. You're visiting us for the first time.
Yeah, this is my first time.
Okay.
So I joined the past 2 sessions in the last 2 months, and then I actually joined to become a member today.
Okay.
But so this is my first time. Don't even have a telescope, so this is very in depth, but it's very interesting. So shows you the depth you
You
can
don't
get
start
into.
here.
Yeah,
So, but it's okay. There's a lot of other places to start.
yeah, definitely.
And people are here to help you do that. And you 3 folks seem to be
I must
together.
be here for moral support. I'm the person without the body.
Okay, well, I thought maybe that was the case, but I didn't want to assume. But great, I'm glad to have you all with us. And I also want to say to we're going through this interesting transition. We keep having, we try to keep having programs here at GMU. We used to have like 200, 300 people. Now we have 60, 70 online, and we had a 60, 70 last night or more out at Sky Meadows. So people are adjusting what they do and when they do it and all of that. And as Paul keeps telling me, the number of people that watch this next week is actually much more than the people that are here. So it's very interesting the way the world is continuing to evolve. And the final, so in one sense, we've got over 1,000 people involved in this, actually more than that, if you count Facebook is over 2,000. So we have a lot of people involved in this and see it in a variety of different ways. So we want to do what y'all want us to do. So we need feedback. We need people to tell us. George does a wonderful job finding us speakers. We all also want to solicit at all times. If you got topics or speakers or something you would like, please tell us. It's hard to read minds.
That's right.
And we haven't got, and AI doesn't do that. It doesn't read minds yet. But anyway, so we don't really know. So, and so we try to cover a whole lot of ground when we do these programs. And so if you have something that you find interesting or something you think we haven't touched on in a while or something that you come across. Years ago, I did one on astronomy. I was just out in Colorado again at the same place. I may do that one again. But I mean, that's the sort of thing people want. We can do that. So we just need to have some input on that. And so we don't have anything else online?
Yeah, we might mention the YouTube channel.
Oh, yeah, sure.
Yeah, on
that's
YouTube, we record all of these, and we have a number of years worth of talks on there. So joining now, you've got the benefit of it.
I've actually gone back and watched a couple of them.
Yeah,
Some are really
that's
interesting.
right.
Yeah. My first one was the Dragonfly presentation, but
Okay.
the first one I joined online,
Yeah.
and that one was really interesting.
It's better to look at the ones that are people that are visiting us because you see the ones that belong here. You see how old we've gotten over the years. Things change, but a lot of us been doing this for a long time. And so the YouTube just keeps it out there forever.
Yeah.
And so everybody should pay it. We have a lot of hits on the YouTube channel. and people look at those all the time. And I'm sure yours will be too, because we'll want to talk about all that stuff.
One thing worth mentioning too is that ZWO has noticed that our club buys a lot of their telescopes. Yeah. And so they've offered us, our club is the only one in the nation that gets this. It's a 10% discount if you want it.
That's pretty cool.
And so if you're gonna buy one, the discount amounts to our dues for 2 years.
Yeah.
So
Nice.
it's,
And that, and for some people, that might be the starting point.
And what is it? One of the electronic?
ZWOs.
yeah, the C-Star.
C-Stars.
Yeah, the C-Star, not the cameras, but the C-Star S30 and the S50 when it comes out.
George, I'm sorry.
Yeah, I got a question for you. I forgot.
Okay.
Your imaging, you do a lot of imaging in Jupiter.
Yeah.
Do you send these images anywhere? Because some people send them to the professionals and they actually use these images and measure storms and how they evolve. on the
I
planet.
put mine on AstroBin and let's see, Facebook, and this alextelescope.blogspot.com has every one of my images that are not a complete blur.
Because I know that some people have imaged the entire planet over a certain length of time. When they
Yeah.
used to do visual drawings, they used to do this.
Mhm.
You can find, look at these books that have just visual drawings of Jupiter, because this was before there was lots of.
And they're helpful.
And you see these long stretches of bands going across where the drawings were made. So,
Yeah, that's a good point, because amateurs contribute a lot to, especially imaging of things in the solar system. And NASA continually notes that when they, for example, find there was another comet that goes into Jupiter that nobody else saw in the system until some amateur says, "Oh yeah, here it is." And so yes, these things happen, and so you can contribute a lot to what's going on. I mentioned last night for the Juno program, they are still looking for people to look at the pictures that are being generated by the Juno cam, because there's a lot of pictures coming down and nobody to look at them. So there's a lot of things you can do in astronomy, and either through the club or just in general, through NASA or some of the other connections that we have. So, but if we don't have anything else before the thunderstorms get here, they're getting closer. We'll just go ahead and close for the night, and certainly look forward to seeing everybody out at one of the outreach operations or at the next meeting. Thank you very much for your time.